Session. Welcome to anybody that's new. We're in the last session. What we did was you try to bring everybody up from. I fiddled around with JavaScript a little bit to okay, I can see the vision for how I write professional JavaScript in the apps that I'm going to create. And in this session, what we're going to try to do is take that a little bit further and really focus on some of the things that we can do in apps with JavaScript. To leave with some good ideas about how to structure them and some good techniques to really get you guys started. Before we get going, if you weren't in the session, I haven't had a chance to meet, just a couple of minutes on who I am. My name's Scott Hillier. That's my contact information up there. Feel free to send me some emails if you have follow-up questions. I'm a SharePoint MVP, been a SharePoint MVP for a number of years, worked in SharePoint really exclusively for the last 10. And I don't think I said this in the last session, but I'll say it now. I've spent the last year really working on this model. I was part of a team that consisted of myself, Andrew Connell, and Ted Panison. See, I'm name dropping a little bit. And what we did was we spent the last year creating what was called the Ignite training, which is the training that was put together for Microsoft's own employees and its partners. And so I've had a lot of time inside of this model. And one of the interesting things about this whole thing is that as I teach people about this new model, it's sort of that, those stages of grieving that you go through, right? Where you first tell people, well, you're going to have to write a lot of JavaScript code now instead of server-side code. And they go, I won't do that. Right? Denial. Not going to do that. Not going to do that, right? But then after a while, after you kind of see what's possible, then, you start to come around, right? So you get this negotiating, right? Negotiating. Well, maybe, if I do a little bit of that, then maybe I could still write some server-side code. So server-side code for, for web parts, but maybe we'll use a little of this. And then finally, somewhere towards the end, it's acceptance. But the idea there, I think, is that you come around to it when you begin to realize the power that you have here and that you're really not losing anything. Because I think everybody's tendency is to think, well, if I'm writing in JavaScript, I must be losing an awful lot. And to be sure, even though it isn't my session, there are other ways to write these apps, right? I mean, if you don't like JavaScript, if you're a person who says, I'm never going to write a line of JavaScript, then you can write apps using C# and the client-side object model, right? So just to be clear about that. But these sessions we're doing are really around JavaScript and the best ways to get that going in apps. Here's our agenda. Again, we're just going to keep it simple and talk about best practices inside of JavaScript, but then also best practices inside of apps. All the code for this session, again, all the code for all my sessions is just stuck in one place on hillier.codeplex.com. If you go up to that Codeplex project, you'll see a single zip file there that has every sample that I'm doing for you. So my advice is the same as it was in the previous session. Steal that stuff because we spent a long time figuring out the models behind that and the good patterns. And I think it'll give you a good place to start. Okay, so let's plow right into JavaScript best practices. We're going to talk about some things that you should always do and try to give you some techniques that are going to be really helpful to you as you start to create these apps. Some simple things like strict mode and equality operators and encapsulation. Some things that are likely very new to the folks in here, like promises, we're going to cover. But all of these, I think, are critical to being able to create good apps in the new model. Okay, so let's start with simple stuff. We'll get warmed up with some simple stuff. So the first best practice is to always use strict mode. The way that you use strict mode is you use the declaration use strict in parentheses with a semicolon after it at the top of a library or inside of a function. And what happens when you use strict mode in JavaScript is you buy into a sort of better version of JavaScript. The idea behind strict mode is that it restricts a lot of the stuff that gets people in trouble. So for example, you can see the list of restrictions there. Can't use a variable without declaring it. My gosh, what kind of language lets you use variables without declaring it? Visual Basic 3, right? I don't know. Right? So you can see all the stuff that it takes away from you. So the idea is to help you write better code. And what happens is in strict mode, it'll just throw a runtime error and basically say you can't do that in strict mode. Speaking of Visual Basic, somebody recently told me, I think it was Rob Bogue, that he likens this to option explicit. Does anybody know what option explicit is? There's the old timers. Me too. Right, option explicit, which is where you bought into a better version of Visual Basic. All right. Okay, so we're always going to use strict mode. Next is to avoid coercive equality operators. I put this one in here because this is a trap just waiting for all of us C# programmers. There are two ways to declare equality and inequality in JavaScript. One is with the equals equals, bang equals, right, which is equals and not equals. And the other is to use triple equal signs, and then actually that should be bang with two equals, not bang with three. Okay. The problem with the first two is they're coercive. So, they try to figure out what you mean, and you see some examples over here, like 0 equals text 0 there, that returns true. And then if you take the same thing, but you use the 3 equal signs, then it returns false, which is probably really the right answer, right? So it doesn't try to coerce the data type. So as a general rule, we'll never use those double equal operators. We'll always use the triple version of it. That can save you a lot of headache. And again, I think it's one that C# programmers will get caught by. Next is the encapsulation of your code. We have talked already in the first session a little bit about the singleton pattern, the module pattern, and the prototype pattern. Again, you're going to see these again and again in the apps that we do because this is really the workhorse of the code that we write in JavaScript. But to review a little bit, this is the singleton pattern. Right? The singleton pattern is the declaration of a literal JavaScript object like wingtip.customer, and that literal JavaScript object can have functions as its values, and then those functions can be invoked using method syntax, which is what you see with wingtip.customer.speak. Right? So that's one legitimate pattern for creating our JavaScript. The next is the module pattern. We talked about this in the previous session a lot, which is the module pattern is a self-invoking function. A self-invoking function we can tell because it has the little parentheses down here at the bottom, which means the function is being invoked and returned into wingtip.customer. The advantage of the module pattern is the module pattern gives you public and private members of the module so that you can hide your code like the variable name, and you can have getters and setters like getName and setName. And then the public interface is defined by the object that you return, in this case, the object with the key set_name, get_name, and speak, returning access to the functions setName, getName, and talk. So no direct access in this case, the way this is designed, to the variable name. That's the key thing, right? And a lot of developers like this. I like this pattern a lot, because you get that public and private interface, which feels really comfortable to me as an object-oriented programmer. But we can get even more sort of pseudo-object-oriented by using the prototype pattern. The prototype pattern gives us a constructor, which is this base function up here, wingtip.customer equals a function. And typically in the constructor, what you do is define the member variables of the object, in this case, name. And then we know now that every object in JavaScript has a prototype, and the prototype is the pseudo class, if you will. It is the thing that determines what a new version of the object looks like, and we can extend the prototype if we want, and then we are able to use the new keyword. That's the real thing about the prototype pattern, is the prototype pattern allows the use of the new keyword, right? So the singleton and the module, really, they're not intended to be used with the new keyword, right? There's some variations to that, but I think in just the first time understanding it, right, if you just want one thing, if you want something to encapsulate some functionality, singleton and module are good patterns. If you're looking to create a lot of something, like a lot of customers, then the prototype pattern is good. The other thing that's nice about the prototype pattern is it's more efficient, because what the prototype pattern does is the instances you create from it, like if they have a speak method, for example, then that code that defines the speak method gets run by every instance, right? So it's a more efficient thing to do if you're creating lots of instances of something. So consider this one. And this is, again, this is a lot more comfortable to object-oriented programmers who like that new keyword because it feels better. All right, so these are the three major patterns that we'll take advantage of in our apps. And we talked about that a lot in the first session, so just kind of touching on them here to make sure that we've covered everything for folks that may not have been in that. All right, So now we're going to move on to something new. The first new chunk that I want to talk to you about is something called promises. Now, this becomes a very important pattern in JavaScript because a lot of the stuff we're doing in our apps are asynchronous calls, right? So even if you haven't written your first app, you already kind of know this, right? Because if you wrote any client-side object model code in SharePoint 2010, right, you know that you have to do execute query async, right? And then you provide success or failure callbacks that get called when that operation is complete. And that pattern of asynchronous calls continues into 2013. So if you're using the client-side object model in 2013, you're going to do that same exact thing where you go execute query async. It's also true if you're calling RESTful endpoints. You call a RESTful endpoint, and then you're going to get a callback that says whether things were success or failure. Now, if somebody stands in front of you and they do a hello world for you that calls a RESTful endpoint, it's pretty straightforward stuff. You have a success and failure operator, life looks good, right? The problem is that's not reality for business apps. What reality for business apps is going to be is multiple calls, right? So one of the things I always found painful about the client-side object model in JavaScript, you with me on that? JavaScript client-side object model 2010. Was that I had to keep making round trips back to the server, right? And then every time I need a success or failure callback function, it gets kind of sloppy after a while, right? In JavaScript, it can be kind of messy. Well, the same thing is true if you're calling RESTful endpoints. You got to make multiple calls back and forth. And what can happen is you can end up with nested calls. See, because the problem is I need a piece of information, and I can't make the second call till I get the first piece of information, right? But it's asynchronous. So you're like, how am I going to do this? Well, the only way to do it is to nest the second call in the success callback of the first, right? And that just gets ugly really fast, and it turns into a big pile of spaghetti. And that was really the problem that I had with the client object model in 2010, was that I often had that going on. Well, what's been introduced is a new pattern called a promise. I'm going to show you a particular implementation of promise that jQuery offers, which I think will be very easy for you guys to get started on. jQuery also calls them deferreds. But basically what a promise does is it makes an asynchronous call, but then immediately returns to you an object. And then the object you can hold on to, and the object is the promise. And the object itself will be filled with the data when the data becomes available, and you can sort of hang on to that, and eventually the data will become available in that object. And then you can actually hold on to the object past that time period, and it opens a very interesting caching pattern as well, which we'll take a look at. So the whole point of promises or deferreds is that what we're trying to do is avoid a big pile of spaghetti code when we have lots of asynchronous calls to make, which we anticipate when we're writing real business apps, and it's not just Scott doing the paint or the calculator or something like that for you, okay? All right, so here is the basic pattern of how this thing works. We're going to look at, as I said, a very particular implementation of promises that jQuery offers us. I think this is a great place to start because we already acknowledge that jQuery is a workhorse of everything we're going to do. I mean, we're really not going to be writing apps without referencing jQuery. It's just so useful. It does so many things for us. So we may as well take advantage of what it has. And so what it offers us is this deferred function. So look at this line of code where it says var deferred variable equals $deferred. That's a jQuery deferred that's coming back here. And then what I'm doing is calling set timeout. So a simple call to set timeout every second. And then immediately returning the promise from the deferred object. You see that? So here's the key. The function is my promise. What's returned? This promise object that's coming from jQuery. So what happens when you make this call to my promise is the call is going to finish before a second goes by, right? That makes sense. So you're going to get back the promise, but the set timeout hasn't run yet. So you're holding an object, but that thing hasn't actually done anything yet, okay? And then the way that it's implemented is the promise object itself has a then method, which you see down here at the bottom. See the then? Okay? and then takes two functions. The first one's success, the second one's failure. Okay? So the promise is returned to you immediately, and then you can write the success or failure functions anywhere you want embodied inside of this. And so what you begin to see here, this is a very simple example, but what you begin to see here is we've removed the nested code. We've moved it out into another place. So it allows you to write cleaner code that isn't a big pile of spaghetti. I mean, imagine if you're making 6, 7 calls, which is not uncommon if you're going back to SharePoint over and over again to load objects or what have you. All right? So that's the basic approach, is you take a deferred object and then you return it immediately, and the deferred has a then that takes the success or failure. When things succeed, you call the resolve method of the deferred. See the resolved right there? And when this is called, the first function will run. See how that works? So every second, resolve gets called, and this function down here will run. Okay? Now, the other thing that's cool about these that we're going to see in the sample that I'm going to work on for you is that once the promise is fulfilled, it remembers the data that came back. So although this is a simple example, in subsequent calls, which we'll see in the app I'm going to do for you, there's no reason to go back to the data source if I already have the answer, if the promise is fulfilled. So it gives me a caching mechanism as well. So not only does it clean up my code, but it offers me a very nice and simple way to cache these calls, which become very important. Okay, let's take a look at that. Well, that doesn't look right at all, does it? It looks great on my screen. I mean, I can keep pressing with this. We don't have the AV guy back there, do we? Let me just see if I can get it to come back. Just take a quick thing here, see if we can change this guy up. If we're not going to have luck on it, then we will just press on. Let's see. Yeah, it was good. That should be the right resolution. It's good enough, right? We can press on. We don't want to goof around with this thing. All right, as long as we can see it, we can press on. Okay, so I'm going to go here now, and well, let's go ahead and run this app first, and then we'll talk about how it's done. So I got to go out on the internet here, so we'll hope it works. But here's what this is. This is an app that uses MusicBrainz. So MusicBrainz is a freely available API that's out there on the internet. Yeah, it works. Okay? And what it does is it returns to you music information. So basically what I'm doing is making a RESTful call out for releases for the artist Boston in this case. And you can see it runs right out there and it grabs, grabs all the releases. We can scroll down here and see them. Okay? And my expectation is that the cover art on the right actually gets filled in by a second call out to a different service called coverart.org. So here's the thing. The first call is going to MusicBrainz just to get information about Boston albums. And the second call goes, okay, now that I understand it's a Boston album, I'm going to go to this other place called coverart.org and pull in the cover art. Now, you can see the updates. It actually updates over here. You can see it hasn't pulled any back yet, but I think I can see red lights on the internet. But you get the idea. So I want you to imagine that, like, way down here, there's a spaceship with lights coming out of it, right? You're with me on this, right? We've got classic rock guys in here, okay? So that's what I want you to imagine. And now let's see how that worked. Okay, so I'm going to come back here. Now, we're using lots of interesting techniques here that I think you'll like. So I'm going to start with the app manifest. Now, the app manifest, right, this is the place where we can specify, high-level properties about our app. And one of the key things that we're doing in this particular example is we're using remote endpoints. Remote endpoints are very cool, in app development, what they allow you to do is actually have the server make a call to the endpoint for you. Now, let's step back and talk a little bit about what I mean. So hopefully everybody gets this idea that all the apps that we're building, when we talk about the data sources we want to go after, the data sources are often RESTful endpoints, right? So that's what we're doing, going after RESTful endpoints. Now, if those things happen to be in SharePoint, like they're a list or a library or search, and we want to get to them in SharePoint, if we want to be in the app web and we want to talk to our host web, for example, then we can do that because we would ask for permission grants to do it, right? So if you have an app web that wants to talk to the host web, then you can ask permission. And during the installation process, it says, this app would like to talk to lists in the site collection. Is that okay? And you go, yeah, that's okay. And then it can do it. What happens if the permission isn't granted? The app doesn't install. So it's just like your phone, right? So same kind of idea. So that's one permission thing. And although I don't do permissions in here, Ted is doing them later today, somebody asked me, so I just want to be clear, that in SharePoint 2013, apps are first-class principals. They have rights in SharePoint like people do. People are authenticated in the normal way using claims. Apps are authenticated using OAuth. That's the model. But both are principals, so they can both have rights. Okay? So when we grant an app a right to talk to the host web or what have you, then it gets rights to do that. It can talk to it through OAuth. You get the idea. Okay, so that's one model, very common. But there's a whole bunch of app development models that require talking across domains. See, in this case, I'm calling MusicBrainz, which is not my SharePoint farm, right? Some other doggone place, right? And I can even talk app to app, right? So I can have one app call another app, which live in separate domains. There's all kinds of cross-domain things that come up when you're doing this. So there are different ways to make cross-domain calls. And I'm showing you one example of how to make a cross-domain call, which is this remote endpoint. When you specify a remote endpoint in an app, what happens is the call is actually made by SharePoint. It's made on the server side. The results of the call are then relayed to you. This is cool because now you're not making a cross-domain call anymore, right? So you're not on the client making a cross-domain call. So it's one way to get around the problem is to do that. And there are a couple of others. We don't cover them all in great detail here, but there is a client-side library that allows cross-domain calls, so you can do that as well. But the point is, it's a very important technique, and that's what you're going to see here, is that we're going to ask SharePoint to make those calls for us. But for us, in the discussion of promises, you can see where we've got two places we need to go. MusicBrainz for the music, coverart.org for the cover art. Okay, great. So now let's go look at the scripts here. So I have lots of libraries in here. Let's go to our song query for starters. Okay, so we have a library called Song Query, and the purpose of Song Query is just to call MusicBrainz and to get that information. Before we talk about the promise, let's look at that server-side call that I was just talking about. So here you can see I have Song Query, right? That's the name of my module. Let's scroll all the way down to the bottom, and you can see in this case that we don't have a self-invoking function. Right, we're just using basically like the singleton pattern here, okay? Here is use strict, right? So you're going to put that in all your code, use strict. One thing to be careful about with use strict can be at the top of the library or it can be in a function. If you're loading other libraries that aren't strict, it is possible to invoke use strict on them and then cause problems where they don't work right. So the recommendation now is to if you think you might be in such a position, you can put use strict in your function at that level instead of at your library level. But just something to remember if you start to see strange behavior. Okay, now the next thing here is that you can see I have this execute method which is going to execute the call. And you can see here is the URL that we would like to call. So this is the MusicBrainz URL, musicbrainz.org, and it allows me to run this query based on artist, and I'm just passing in the name of the artist, Boston, right? And that's going to run off to MusicBrainz, and then it's going to return to me a bunch of XML stuff that has the information in it. But remember, we're not making the call from JavaScript. We're asking SharePoint to make the call for us. How is that done? That's done by using a new SP web request info. So there's the combination of the two things. You specify a remote endpoint in your app, and you utilize the web request info. And what the first one does when you specify that remote endpoint, it tells SharePoint it's okay to call. That's a trusted endpoint, it's okay. And then this one actually invokes that call. So we're going to make the call, and then we do a classic execute query async with success and failure callbacks. Here they are. Now, so that's the server-side call. Now let's layer on top of that the promise. So what we do is we come in and we say, here's a variable, deferred, and then here's a success and failure function. And in those success and failure functions, I'm going to call either resolve if we're successful or reject if we fail. And the other thing is that you can see the execute method, the return from the execute function, is the deferred itself. See how that works? So even if this thing hasn't run yet, I'm just going to immediately return an object to you. When it does succeed or fail, we're going to call the success or failure off of that. All right, so hold on to that. Now, let's go to the code that's actually making the call to execute. Okay, so what happens here is that we make a call to execute. Here it is right here, musicbrains songquery.execute. Now, a couple of things that are really interesting here. One of the things that's interesting is that if we roll up to here, I'm going to keep all of the deferred objects in an array. Even after they succeed, I'm going to hold on to them here. And then what I'll do is that when you call load, I'm going to come down here and I'm going to check to see if this query has already been run. And the way I'm going to do it is by looking through the array of promises that I have at the artist property and see if the artist you're searching for is already in one of the promises. See how that works? If it is, then I'm going to set the active promise equal to that one. Okay? But in the first round, that won't be true. So if it's not true, what I'm going to do is add a new promise to the array, and I'm going to call musicbrains songquery.execute. Now, the other thing that's interesting about this pattern is I was using kind of a singleton pattern, not a self-invoking function, but I'm using the new against that module. And the reason I'm doing that is because I need a new promise back every time we run the query. If you don't make a new instance of this thing, then the promises will step on each other and it doesn't work right. Right? So then I get back a new promise. And then if you look at the code down here, whatever that active promise is, I call the then method on. And here's the function if we've successfully retrieved the song data. And then here's the function if we failed. Okay? And then what happens is, if you were to run that Boston search again, it would happen instantaneously. Because we would use the active promise would be the one that contained Boston. And when we called then, the success function runs immediately. So we've done two very interesting things here. We've moved this processing code out of the query library. Right? So look, song query, if you look at it, song query is very clean. See that? It's very clean. I can fit it all on one screen here for you. That's a very clean RESTful API call that's either succeeding or failing. And it doesn't really know anything about what I want to do with the data. See that? It doesn't have any idea what I want to do, and it doesn't care because it just returns a promise. So I'm factoring out things like what element is this going to be displayed in, right? Rob Bogue, who has a few sessions this week as well, is doing some very interesting work on a larger library for REST calls that only returns promises, so that you can make any REST call in SharePoint and just get back a promise and just reuse that library over and over again. So that's pretty interesting stuff that he's working on. So I think that pattern is more than just a curiosity, right? I think that becomes a thing that we all should be doing, because you can see how clean it is. Okay, so now though, right, now what happens is I get the songs, right, but now what I need to do is I need to make calls for the cover art. So I have these nested calls, and I can't make a call for the cover art until I have the song back, because I don't know what the album is or what have you that I'm going to go get the cover art for. So I have another query here, another library here, which is the art query. And the art query follows pretty much the same pattern. See how I can fit it on one screen? And the only thing that's different here is that instead of going against Music Brains, it's going against cover art to retrieve the cover art for a particular ID that I'm sending in. It's still using that SP web request info, right? So that is a server-side cross-domain call that has to be made, and we told it was all right because of the remote endpoint. Okay, if we go back now to the code that's actually invoking all this business logic, and we scroll down, you can see that to get the associated cover art now, we'll follow basically the same pattern where we have the execute and then the then. And if we're successful, we're going to go ahead and update the song information to show the cover art. So again, the idea behind this pattern is it simplifies multiple RESTful, or even, you can use it for client-side object model stuff too. So it doesn't matter whether you're using the JSON or the RESTful endpoints. It simplifies that code so that you don't have nested calls across complex applications. And it implements a very simple caching scheme that should the same call be made to the RESTful endpoint again, you're going to get back exactly the same results. Okay? All right, cool. Let's see how we're doing. All right, more stuff. Next, we're just going to talk a little bit about managing libraries in JavaScript. So when we talk about libraries, we definitely want to be segregating the code that we write into libraries. You see that in all the examples that I show you. I have my, my song query, my cover art stuff, all segregated into libraries. And we're striving for reuse, right? So we want to be making libraries that are going to help us reuse. One thing to keep in mind about segregating your code into libraries is that you really don't want too many libraries, because it turns out that it's much less efficient to call for many, many small libraries than it is to call for one big library. So you give some consideration to how your libraries are packaged at the end of app creation, and maybe some of these libraries go into the same file to make them faster to download. Along with how you package your code into libraries, you want to minify those libraries, right? So this is the idea, of crunching the libraries down, because when we create the code in JavaScript, certainly the stuff that I've been showing you, it's all formatted for reading, right? We got to look at it and edit it, and it's all pretty, and I like my curly brace at the end. No, I like my curly brace on the left. 2 spaces, no 4 spaces, right? And all this sort of wars people get in over how JavaScript is supposed to be structured. But then in the end, what we want is all the white space and carriage returns and everything else removed so the thing is as small as possible. And that's what minifying is all about. There's some pretty simple tools to be able to do that. I'll show you that in just a second. Then when it comes to libraries, we need to consider how those libraries are delivered to the end user. And you have a couple of options for that. So one is simply to put the libraries in the JavaScript folder in your app and just deliver it. You can do that, right? Just push it out there with your app and have it live there. That's okay. But there's a couple of other options that are better for managing versioning. One is the use of a content deployment network, or a CDN. What a CDN does is it takes the libraries and puts them in the cloud, and then you can reference the cloud CDN. And the idea is that the reference there will always have the most up-to-date version of that library. So if you were to consider making many, many apps that all shipped the library in the app, right? And then they're up on the marketplace and people are buying them from Office 365, and then you make a change to that library, well, since those libraries all got deployed with the app, right, Now you have to update the apps, and then everyone sees a little message that says, there's a new version of your app, would you like to download it, that kind of thing. But if we had it on a content deployment network, then a change in the content deployment network would allow the apps to reach up into the cloud, get that library, pull it down. When things are in the content deployment network, they get cached on the local browser, right? So it's not like you're pulling them down every time, so it's a pretty efficient way to do it. So something to consider when you're pondering the scope of these libraries that you create. How many apps am I going to use them for? Is this a commercial thing I'm doing, or is it an on-premises app for HR? You know, those are all going to impact your decision. And, finally, the use of SharePoint libraries. So we saw in the app that I just ran for you that we actually were using a SharePoint library, sp.webrequest. Now, when you're doing JavaScript development with these apps, you're going to find that you quite often need to reference functionality that are in SharePoint JavaScript libraries, which can all be found in the layouts directory. Everything's in the layouts directory. So you want to use some functionality that's in there. So for making a server-side cross-domain call, or for generating Chrome in your application, right? All these things are functionality that SharePoint can provide for us. So you have a couple of ways that you can use them. One way is you can certainly grab that library, sp.webrequest.js, and you can put it in your app. And you can just reference it right in your app, and you can push that out there, and that'll work fine. But that doesn't guarantee that if that library was changed by Microsoft during a subsequent service pack, that your app would actually use that library. So instead, you can consider loading the SharePoint libraries dynamically, which allows your app to reach into the hosting farm, into the layouts directory, find the library it wants, and load it. And that way, you're guaranteed that you're getting the most recent library. So the considerations around libraries are all about size and speed and making sure that people have the most up-to-date version. Okay, so we'll look a little bit about that. Minification, this slide talks about minification. Minification is really simple. You can use the Microsoft Ajax minifier. It's a command line utility that basically takes a JavaScript library that you want to squish, and then the name of the library you want it to be when you're done squishing it, and it squishes it. There you go. So you can see the Ajax minifier here in this simple example took a 658-byte JavaScript library, which is formatted politely for me to read it, debug it, show it to you guys, and squished it down to 377 bytes, and there's the output over there. Obviously, you wouldn't want to have to work with that in your development environment. So that's a really straightforward operation. Just get that Ajax minifier and use it. There were some tools in 2010. I haven't seen that they're yet available in 2012 from the community where people actually worked these into Visual Studio so that you could just have it in Visual Studio and tag a file. And the beauty of that was when you built the app, they get crunched for you. So there were some community tools in 2010. I wasn't able to find any for 2012. If you know any good ones, let me know. But that's pretty handy because then you can just sort of tag the file and put it out of your mind. Content deployment networks. Here is the classic example of using a CDN. This is using a CDN to load jQuery. So when you use a CDN to load it, you're basically just pointing at some location in the cloud and using the source attribute of script to download that library. You can see here we have the example from the Microsoft location as well as the Google API's location. So this is the preferred way to incorporate jQuery into your application as opposed to shipping the entire jQuery library. And again, this is something that you can consider doing for your own libraries, putting them up in a CDN, particularly if they're going to be commercial libraries, and making them available to your apps that way. It's a very straightforward thing to do, just need a place to host them. And lastly is the loading of SharePoint document libraries. So this example code that you see right here is just showing you the basic steps involved in loading a SharePoint document library from the hosting SharePoint farm. So you can see we've got the document ready function, which is just the jQuery function saying, hey, everything's good to go. And then what we're doing is we're retrieving the host web URL, right? So let's make sure we get our terminology straight. App web refers to the web that is hosting your app. Host web refers to the web that is the parent of your app web, okay? And it is the host web URL that we're going to be reaching back into in order to get the library that we're interested in. So what happens when an app is created is that if you look in the app manifest, you'll see that the app is going to pass to you certain query string parameters every single time. And you can rely on these standard tokens, they're called, to be present in the call that's made to you when the app launches. And you can see here that we have SP host URL and SP app web URL, which are some of the standard query string parameters that you receive that basically tell you what you need to know, like who's my host web, so I can call back into it, right? And then down at the bottom where you see var script base is host web URL layouts 15. Now what we want to do is we want to reach back in, and we're going to ask for that SP request executor. Here's a JavaScript library we would like to use. In order to use it, we're going to use the jQuery get script method, which is basically going to reach back in and dynamically load that library. So this technique is preferred for SharePoint libraries because it's going to guarantee, again, that you get the most up-to-date library. If Microsoft runs a service pack, then this code will pull out the correct version. Okay, so let's take a larger look then at just some good practices. And what we're going to do, let's get the right app open here. All right, let's just take a look at an app that we can sort of pick on for some best practices. And this is my contacts app here, my HTML5 contacts app. I showed in the previous one, but basically this is really just performing CRUD operations against a contacts list. So if we come over here, a couple of things to point out that we'll be taking a look at. One is that notice that I have some Chrome on this, and by that I mean that I have this blue stuff up here, I have my title, right? So when it comes to the UI standards for apps, one of the things you want is for the app to look like it belongs to the farm it came from. And since you really don't know the styling of the farm it came from, we need some help in getting that information, right? So we do that with something called the Chrome control. So we're using that right here. The other thing is that when you make an app, you need to create some sort of navigation for it, right? You need a way to move around it. And the Chrome control helps us with that as well. And it's actually generating this gear menu for me over here. And we'll see that as we go along. So I can come over here to this gear menu, and I can pick contacts. And we'll see that what it does is it runs off and it reads the contacts list and brings me back contact information. Simple stuff, okay? And now we can go ahead and add a contact. And we'll just come in here. I don't think I actually added it last session. We were just looking at the form. So let's go ahead and see if we can add it this time. Put my name in there. Typing in phone number. Okay. Validates. We'll go ahead and submit it. Looks like we've been successful. We'll come back to the contacts view here. And, let's see, refresh. There it is, okay, and I'm in there. All right, so we're just performing simple CRUD operations on a list. But inside of this admittedly simple idea of just reading and writing to a list is information about a lot of our best practices. So let's go ahead and take a look here. All right, so let's go look at the Contacts app. Now, the first thing I want to show you is, let's just go in here to this particular library right here called the spinner. So one of the things I had said when I demonstrated this before is that when the table is filling up, there's a little spinner that goes on, you know, the I'm waiting to get some data thing. And I just wanted to point out that that little spinner was made with HTML5. So it's not a, it's not an image or what have you that's up there. It's made straight up with HTML5. This is the library that does it. Again, you have access to this information. But it uses a canvas. So here's the canvas that we're going to put that little spinner on. And then what happens is we use a set interval because we're going to draw different things on it as it spins around and around, right? And then you can see down here that basically what we're doing is we're creating arcs and strokes and drawing on that canvas surface to create this thing that goes around and around. So I think the takeaway from just the idea of the canvas is that many, many things that we did to add sort of pop and, status information and that type of thing to our apps now can be done pretty straightforward with HTML5 without adding any additional things. And then you have this nice reusable library that you can use. Okay, so let's point out a couple of things in here just that are easy to understand. So we've got our strict, right? So all the code I show you, you should see that we're using use strict. This is what you want to do. Again, some consideration about putting it up at the top or putting it inside of a function, but everything should have it. You can see our encapsulation patterns, which we've talked about several times now, hoping this is starting to stick in for you guys. So we've got this spinner that we're creating. If we scroll down to the bottom, okay, we can see that this is a self-invoking function, which is a pattern that I follow quite a bit. We can see that we have an init method here that basically fires up the canvas and then starts the drawing, right? And I really don't need an awful lot more than that. Okay, so those are all things we've talked about a little bit. Something new then is you'll notice in this app that under my scripts section here, I have both a debug and a release folder inside of here. So in my debug folder here, this is where we're going to see, if we go to the spinner, this is where we're going to see the nice readable version of the spinner. And then if we go into the release folder inside of here and we look at the spinner, this is where we're going to see the crunched version or the minimized version of the spinner. So this is important for you because obviously when we're writing code, we want to work against the debug version. And then what you're going to do is take these libraries, and the next thing you want to do is reference them inside of references.js. So the app project itself has this underscore references, and you can use this triple whack reference syntax to reference the various libraries that you have inside of your app. And then what you're going to get for this effort is you're going to get some IntelliSense out of the library. So that stuff becomes really important, right? Because one of the hardest things about writing JavaScript is we're not getting any IntelliSense. So this stuff is all stuff you have to add by hand. But basically you can see that what I'm doing is I'm using the debug version of the library to provide my IntelliSense. So all of my work is done with the debug version. And then I just squish up the debug version into my release version when I'm ready to go. And if we come look at the actual page, and you look at the references for the page, what's happening is I'm going to reference the release version in the page, not the debug version, right? Because that's the one we really want. So that's the best way to set it up, I think. You can have debug and release folders with your full version, your squished version. Make sure the pages reference the actual release versions. And then you just use the Ajax minifier to squish them down. If we go look at the actual code, the project folder for this, into the scripts. Okay, here's the bat file for minification. Let me just show you how simple this is. So you just call the Ajax minifier, and it's a simple matter of saying what it is that you want to minify, right? So there's capabilities viewModel.debug, and then the output file, which is just capability viewModel. It's that simple. It's ridiculously simple. It's an input, it's an output thing, and you can get the small version. So again, that's a best practice. You definitely want to incorporate that part into your apps. Okay. Let's bounce back here. We'll come back to this app again and look at some other things as we go forward. but I want to talk about them first before we dive into them. So now we're going to sort of move into what we'll call app best practices. So I'd like to think after a couple of hours of talking about this stuff, everybody has a pretty good vision in their mind about how to structure the JavaScript code. So now how do we move on to do the things in apps that need to be done? In particular, we're going to talk more about REST, what patterns are we going to use to talk to REST. Then we're going to talk about the model view model pattern. So one of the challenges you have with these apps that you're creating is exactly how are they supposed to be structured, right? Because JavaScript is one of those things that's so loose that you can make the app work, right? I mean, I don't need to teach you another thing. You guys can go off and make the app work. But the question is, how do you make the app work in a way that's maintainable? And I'm going to suggest to you that the best way to do it is to use this model view model pattern that I'm going to present for you. And then finally, we're going to talk a little bit about the app UI guidelines. I'll show you how to make sure your app looks like the farm that's hosting it, so it doesn't look like some garish thing that doesn't belong in there and shocks people when they launch it. Okay, so representational state transfer. So I talk about REST a lot. I've said REST a lot in here. When you think about creating apps, there are actually 4 permutations of app development that you can get involved with. We can use either JavaScript or C# to do our work, right? So I've explained to you before that there are provider-hosted, auto-hosted, and SharePoint-hosted apps, right? Auto-hosted is O365 only stuff. Provider-hosted, you roll your own infrastructure. SharePoint-hosted is hosted by SharePoint, no server-side code allowed, only declarative elements and JavaScript. But when you think about those 3 things, SharePoint-hosted, auto-hosted, and provider-hosted, and then you think about the programming languages that we have available, C# or JavaScript, you end up with 4 things that you can do. So you can write JavaScript against RESTful endpoints. You can write JavaScript against the client-side object model, right, just like you did in 2010. You can write C# against REST, and you can write C# against the client-side object model. And you could be forgiven for wondering which of those 4 should I be doing, right? Let me try to make it easy for you. In my opinion, there's only 2 viable choices here. One is to write JavaScript against REST. The reason that you would want to write JavaScript against REST is that all of the third-party libraries that you're really going to want to make use of, like jQuery and Knockout, they really just work seamlessly in that environment. It's clean, you write less code, it's easy to maintain. It's just a much better experience if you're using JavaScript. So, in my mind, and we'll talk more about Knockout and things in just a minute here. So in my mind, one viable pattern of app development is JavaScript, REST, the MVVM pattern, SharePoint-hosted app. Get that? So if I were an on-premises developer, I'm part of a SharePoint team at a large organization. We have no plans to move to the cloud, but we'd really like to go into 2013. Some of the app stuff seems really cool to us. I could see us doing that. Then I think that you're a really strong candidate for JavaScript, REST, MVVM, SharePoint-hosted app. It's clean, it's simple, it's easy to do, right? And I would prefer, personally, to do those before I got to provider-hosted, which requires me to roll an infrastructure. If you want to argue it with me, you can buy me beers later. But I think that's one really viable choice. Now, again, I said this before, but if you look at me and you say, I hate JavaScript, we're never going to write JavaScript, it's not a real programming language, and I'm a hardcore real programmer, right? If you're that person, then your model is C#, MVC4, provider-hosted app. So what you're going to do is roll your own infrastructure where you can drop your ASP.NET applications. I'm going to recommend to you that you use MVC4, Model View Controller, MVC4, because it gives you a really nice pattern. And then your approach is going to be client-side object model. So the second viable approach in my mind is provider-hosted, C#, client-side object model, MVC4. I don't talk about any of that stuff in these sessions because they didn't hire me to do that one. But to me, those are the two things. So I tell you those things because hopefully you can just like hang those on pegs in your mind and go, those are the two things I should be thinking about when I'm writing apps. Okay? Now, to be sure, there are hybrids of all of that, right? You can do hybrid versions of that. So just because you wrote an MVC4 app doesn't mean you can't write JavaScript, right? So you can write some JavaScript in there if you want. But those are the two main buckets in my mind. So as we're focusing really on JavaScript, to me, that means we're focusing on REST. We really want, I think, a bias towards using the RESTful API and not the client-side object model, although I'll make it clear that the techniques I'm showing you can work with the client-side object model. I just think it's messier. Okay? I just think it's messier in JavaScript. Okay, so REST is not only important for us as JavaScript developers, in our context here in this session as JavaScript developers, but it's also a very important standard on the internet, right? So when you think about Music Brain's cover art and all that other stuff that you can go out there and get, they're not delivering that to you as a JavaScript object model that SharePoint understands. Those all come to you as REST. So why would I want to mix all that, right? All the data stuff that I want to talk to are RESTful endpoints. It makes sense to really focus on that. So REST is a key, key architectural approach for us. And of course, the reason this is cool is because of the Open Data Protocol, which is mapping those CRUD operations we perform in REST to get, post, put, delete, and patch operations. So basically what that means is that as long as you can speak HTTP, you can be an app, right? And that's why it opens this door to doing other things in other non-Microsoft languages and platforms that can also be apps, right? So that's very cool. So my recommendation to you is really to focus on the idea of REST. Just to make sure we're all on the same page, what's going on with the RESTful endpoint then is the real change in 2013. If you think about what we had in 2010, I used a version of this when I taught 2010. It didn't have the purple OData thing over there. But basically what we had for the client-side object model was a JavaScript library, Silverlight library, and a managed library in .NET. Those three libraries exist in 2013, right? So we still have those same three libraries, greatly expanded. But the endpoint, client.svc, that they referenced was not good for REST, right? Like you could not make a REST call against client.svc. Instead, we had listdata.svc. You with me on that, right? But listdata.svc was just for lists. So listdata.svc is not cool anymore. We don't do that anymore. Instead, what they did was they expanded client.svc to allow RESTful calls against it. So no more listdata.svc. It's still there, right? So if you have a listdata.svc thing, you're good to go. But we want to make all our calls against client.svc. And the new alias for that is _API. So when people talk about _API, they're just talking about client.svc expanded to accept RESTful calls. That's it. That's all there is to it, right? Okay, so this shows you a couple of techniques for making RESTful calls using JavaScript and jQuery. jQuery, again, is our workhorse. There are two key ways to make RESTful calls. One is with the getJSON method that you see at the top here. The other is with the AJAX method. We've seen a little of the AJAX method. I don't think we've tripped over getJSON yet. GetJSON is a simplified way to make a RESTful call. You basically can do it in one line here where you can provide the getJSON, and then this is the URL of the thing you want to call, or URI, right? This is the URI of the thing you want to call. And then the function is the success function that happens right here. So basically, when you're a REST programmer, your entire life is around making the correct URI. Because once you make the correct URI, everything else is the same pattern, right? Just do the same thing. Pull it out of there and show it somewhere, right? This, I think, is pretty cool if this is just some complete side bar here. But this is pretty cool because you see this _API web current user call that I'm making right here. That returns you a grunch of information about the person who's currently looking at the app. So that's how I'm able to welcome you and show you your picture and stuff. So that's a pretty cool endpoint to know. But basically, that's the same as what we used to do on the server-side API, right? So what's really cool about the RESTful API is that a lot of the construction of the URI follows the same things you know from the server object model. So sometimes you can kind of guess, it must be this, and then put it in and it works. And you're like, I'm the smartest guy, right? So, But that's the hardest part about this whole thing, is just figuring out exactly what the RESTful endpoint is you have to call. So get JSON is really simple if you just want to make a quick call like this. The other thing is that, I don't think I'd said this out loud, so I'll say it now, is that this returns a JSON object. So a JSON object is a really cool way to get data back from REST, because basically you can access it immediately as dot properties. So if you look up here at my getJSON, see my success function floating around over here has a parameter here called data. And then when I get it back, I just go data.d.title. So even though there's a big mess of ugly XML that comes back streaming down the wire to me, when I write the code, I can just go data.d.title and pull out the title of the current user. Very cool. So the model that you want, your preferential model, is to make RESTful calls and return JSON. You can return raw XML, that's legitimate, but why would you want to? Because then you have to parse it, right? So in all cases where you can, your goal is to make a RESTful call, return JSON. If you look at the AJAX method down here, the jQuery AJAX, this is just a longer version of getJSON where you provide the URL. This is a get. Notice the headers here where we're saying what it is that we accept. This is really important here, this application JSON OData equals verbose. Basically, these headers say what kind of data you want back, and it has to match what the web server is willing to give you, what the service is willing to give you. And so, anybody in here have did you get a giveaway of the app book we were giving away in the, just one guy, that's it, you're the one reader, yay, woo. All right, so I just wanted to point out that a lot of the samples that you see out there, they may not have this exactly right. They may just say application JSON, because very late in the cycle, Microsoft formalized these strings, and now you must say application JSON, and that shouldn't be a question mark, OData verbose. That should be a semi, right? So the point is, you'll see it in the code. I'll show you, make sure I point out the code. But the point is, you have to have that right, or the server will say, I don't return that, okay? All right. Okay, so that's the RESTful stuff. Now let's talk a little bit about model view, view model pattern. So now that we understand that, we sort of have this bias for JavaScript and RESTful calls returning JSON, now how do we structure those calls in a larger way to make an app? And the answer is we want to use this pattern, the model view, view model pattern. So what is this pattern? Well, it consists of these three things shown in this diagram here, which, unsurprisingly, are the model, the view model, and the view. But what the heck does all that really mean? Well, basically, what this pattern is trying to do is isolate the functionality of getting and retrieving data from the process of displaying that data, so that the way you display it doesn't impact how you get it. That's what we're trying to get, right? And then that's the point of all tiering ideas, right? Is that you separate the functionality of the tiers. This just happens to work really well with JavaScript and the REST stuff. So what the view model does is the view model is an object whose purpose is to read and write to the data source. In this case, we're saying SharePoint. Reads and writes to the data source. It fills the model with information, and then the view model sends the model to the view for display. So if we were retrieving information about a contact, the view model would read and write to the contacts list. The model would be a contact who would be filled in, set of contacts that would be filled in, and it would be sent to the view to be displayed as a grid. See how that works? And the beauty of this pattern is it gives you the kind of separation we really want as developers if we're trying to make professional applications out of JavaScript. The way that you're going to implement this is by using a third-party library called knockout.js. Now, when it comes to this idea of separating functionality from display, there are lots of libraries, lots of templating systems out there. Everybody has one. But what happens is people kind of vote with their code about which one is working well and which one has the features that they need. And I'm going to suggest to you that Knockout is the one that's currently in the lead that you should use. What Knockout does is it has two key things in it that you really care about: declarative bindings and dependency tracking. What this is going to allow you to do is make a declarative binding between objects in your code and the page. And then it's going to track the dependencies so that if one of those objects changes, the page is updated automatically. This is exactly the same model that Silverlight follows. And it's been very successful in binding objects to XAML pages. And when those objects update, the XAML page updates automatically. So that's really the genesis of this library, is it comes from that same idea. So when it comes to declarative bindings, it's also pretty straightforward to use. So here's a page that has a div in it and a table that's going to show the contact information that we've been looking at. And here's where you want to focus on the stuff that's in red. You see this data bind right here? For each get contacts. So get contacts is a method that's going to return an array of contacts. And then each contact has methods like get last name, get first name, and get phone, which will be data bound into this row. And basically what's going to happen is that for every contact that comes back from get contacts, they'll be bound into a new row in the table, and that information will be displayed. So this is a really simple thing to do. This is what Knockout enables. And you can see that I now am gaining separation from how things are displayed versus the reading and writing to the list, which is exactly what I want, so I can reuse my libraries. In code, then, what happens is we have this contact view model, right? Because it's the view model that reads and writes to the list and sends the data for viewing. We've got a new variable in here, contacts, which is a KO, that's the Knockout namespace, KO observable array. So what makes all this stuff really hum is this KO observable array. So I can declare a variable as such and then fill it with contacts. And if one of those contacts changes, then the array triggers that there's been a change to the data it contains and redraws the page for you. Now, the thing to note here that's really important is if you look at this pseudocode that I have in front of you, right, this partial code I have in front of you, notice how it doesn't know anything about the page. It has no idea we're displaying this in a table. Now, if you're really paying attention to some of the demos I did before, I did ugly stuff where I actually generated HTML in the JavaScript and then streamed it out. Yick. We don't want to do that, right? So this has no idea what the page is that's going to display it. And similarly, this has no idea of the code that's generating it other than the dependency on the names of the method. But you can change what's going on in there, right? You can do maintenance and change what's going on in there without impacting this page. That's really, in a nutshell, what MVVM brings to you, and that's what Knockout implements for us. Okay, last thing to talk about here is the app UI guidelines. So when we make an app, as I said a couple of times, we really want that app to look like the farm that it's a part of. And we have 4 choices for doing that. The app project template, a web template, Chrome control, or custom branding. If you just use the app project template in Visual Studio and you just say, give me a new SharePoint hosted app, then it makes for you an ASPX page that already is going to take on characteristics of the host web. Okay? So this is the big no-brainer right here. If you just use the project template in 2012, you'll be okay. Now this uses ASPX pages. You can also, to that same thing, apply a web template. This is the same web template stuff that we know and love from 2010. So if you have a web template definition, you can see in the app manifest that there's a place to specify the feature ID of the web template that you want to use, and that'll get applied to your app. If you're not using ASPX pages, if you're using HTML, then you're not going to get this automatic chroming of your app. And so instead, what you'll want to use is something called the Chrome control. The Chrome control comes from the library sp.ui.controls.navigation. So it's a SharePoint library found in the layouts directory. And what it does is it takes the URL of the host web. Remember I said when your app starts, you are passed in certain standard tokens. One of them is the URL of the host web. So this object, sp.ui.controls.navigation, takes the URL of the hosting web. and it uses that URL to reach back into the layouts directory, and it makes a request for the style sheet of the host web. Basically pulls back the styles of the host web, and then it uses those to color up your page for you. So if you drop this into your app, then your app will take on certain characteristics of the host web, no matter who uses you. So this is really your strategy if you're an Office 365 marketplace person, right? Because you really want your app to kind of look like wherever it drops, but you have no idea. So the Chrome control helps you do that. Additionally, if you look at the setting links part of the object up there where it says link URL page 1 method 1, the other thing that Chrome control does is the Chrome control allows you to create a little navigation system. I showed that to you. There was a gear in the upper right-hand corner, and when you dropped it down, you had a list. That list is coming from the settings links inside the Chrome control. So it draws the nice little bar for you. It gives you the gear. It gives you the drop-down that you can use. All right. So now let's just take a quick look for our last thing. I got 5 minutes. Excellent. Let's go ahead and take a look at MVVM with Knockout. So I've already run this thing for you, right? So I won't go through it again because we have 5 minutes, but basically we're doing CRUD operations here. So let's take a look at some of the things that we've been talking about. First, you'll notice inside my code right here that I have Knockout. So there's the library, knockout-2.1.0. That's implementing my MVVM pattern. Okay? If we look in the page for this, let's look in the page that displays the contacts. That's what we had on the screen. Here's my Chrome control stuff all up here. And you can see a lot of things coming together. This is the nav tag from HTML5 that defines the navigation section. This is the Chrome control politely stuck in the nav section where it belongs, right? And then we scroll down here, and here's the table that has get contacts, and it has get last name, phone, email. This is the binding of the data into the page. Now, if we come to this library, let's go to the debug version. If we come to this library, we can see that this library, I define a contact. So there's two modules in here. One is a contact, and the contact just provides last name, first name, phone, email, right? So that's just like a basic payload class. You with me on that? And then I have the contact view model. The contact view model executes a RESTful query against the contacts list. If that succeeds, then it comes down to the success section here. And basically what happens, let's scroll to the success here. Basically what happens here now in success is you can see that all it does is create new wingtip contact objects and shove them into the contacts array. This line of code right here, apply bindings, binds the contacts in the array to the page as I showed it to you previously, and every single contact in the contact model gets applied to the results table. See how that works? So this is really just the same thing as taking a data grid, splatting it on the page and going data bind, right? It's exactly the same idea. But the beauty of this is that you can set this stuff up so that you have a much larger disconnect between the different layers of the application. All right. So I think we're in good shape. Let's bounce back here, see if we have anything else to say. Okay, so that's it. So we talked a little bit in this session about JavaScript and hopefully gave you guys some best practices. I want you to think about the different patterns for encapsulating your code and how you keep that stuff out of the global namespace. And then finally about app best practices, right? So we're thinking JavaScript, REST, MVVM patterns in our apps. I think we're right at the end here. Everybody's heading out. They're trying to beat you to the ice cream. I will stay around if you have questions. Thank you.